Hello everyone and welcome back. So in our last lecture we learned some applications of Gauss divergence theorem, and in this particular lecture we will learn another important theorem which is called Stokes theorem, and this is nothing but a relation between line and surface integral. So line means single integration and surface means double integration. So what the statement says, if S be an open surface bounded by a closed surface or closed curve C, and one vector function is given which should be continuously differentiable like the other statement, then integration over C f bar dot dr bar is equals to integration over S curl f bar dot n cap ds. So n cap we already know from Gauss divergence theorem, it is unit external or outward drawn normal at any point of the surface. Okay, now let us try to understand this particular statement. Suppose if we take a closed curve C, this is the closed curve C. Suppose this is a three-dimensional figure, but whenever we see the shadow of this particular figure, then what we'll get? We'll get a semicircle, right? This is a hemisphere, half of the sphere. So the shadow of this particular, suppose I'm talking about this semicircle. Now this is a closed curve, okay, closed curve. But the whole surface, right, the whole surface is what? This S. So on this particular surface and in this closed curve C, if we have a vector function which is continuously differentiable, then integration f bar dot dr bar, so this part we already get in what? Green's theorem, is equals to double integration over S curl f bar. So curl means what? Nabla bar cross f bar. So I hope you know how to find curl f bar, which is I cap, j cap, k cap, and then what? Del del x, del del y, del del z, and then the components of f, which are f1, f2, and then what? f3. Okay, f1, f2, and f3. Now this n cap is what? If we draw a perpendicular outside, then along this direction the unit vector is what? The unit vector is n cap. Okay, so n cap has some values also. N cap, since it's a direct vector, no, so along x-axis it has some component, along y-axis also it has some component. So we can write like this: cos alpha I cap plus cos beta j cap plus cos gamma k cap. Now the thing is that why cos alpha, cos beta, cos gamma? So let me explain. Okay. Suppose this is the curve, this is x-axis, y-axis, and then suppose z-axis. Okay. Now if we take this n cap, no, n cap, so n cap is what? N cap is nothing but a direction. So suppose this direction is what? N cap. It is drawn on some surface. Now you see this n cap makes some angle with x-axis, some angle with y-axis, and some angle with z-axis also, right? And suppose this is gamma. Then we know that if a vector makes alpha, beta, gamma with x-axis, y-axis, and z-axis, then it can be expressed like this: direction cosines, cos alpha I cap, then cos beta j cap, and then cos gamma k cap. Okay, so in the detailed proof I'll explain all these things, but in this particular lecture we'll just stick to the statement and do some application of Green's theorem, and not Green's theorem, sorry, Stokes theorem. Okay, now let us see some application of Stokes theorem. So verify Stokes theorem for a bar. So in place of capital F bar, a bar is given, it is twice x minus y I cap, and then y z square j cap, then minus y square z k cap. So this is the vector function where S is the upper half surface of the sphere. So this is one sphere, x square plus y square plus z square equal to 1. So upper half surface means, so suppose if we draw a sphere, So this is a sphere. Okay, so the surface, no, this whole surface is S. So upper half surface means we just take this part, upper part. Okay, this part is upper half surface. And x square plus y square plus z square equals to 1 means the radius of this sphere is how much? Is 1 unit. Now if we take this upper half surface and rotate it again, then again we will get this particular sphere. C is the boundary. C is its boundary. So this curve, no, this curve is what? C, and the whole surface is what? S. Okay, now here C is the what? Here C is the upper half surface, which is of the sphere, which is nothing but what? A circle, which is the circle. So when you talk about curve, right, curve, then it will be a two-dimensional figure. So its equation of sphere is given here, but if you talk about the curve, then since it is two-dimensional, so it will be x square plus y square equals to how much? 1. So z is absent. If you want, then you can put y is equals to absent, then it will be in xz plane, or if you put x equal to 0, then it will be in yz plane. But it's better if you put 0, then we will stick to xy plane. Now, can you tell me what is the parametric equation of this curve, circle x square plus y square equals to 1? Parametric equation means, since here you see two variable, no? So we have to write the equation in such a way that if you put a single variable, then this particular equation will satisfy. So the parametric equation will be like this: x equals to, suppose, cos t, and y equals to how much? Sin t. Now if we put cos t here and sin t in place of y, so cos square t plus sin square t equals to how much? 1. So these are called parametric equations. Okay, parametric equation, because since it's a single integration, no, when you write Stokes theorem, single integration, in single integration you cannot take two variable x and y, so that's why you convert it to what? Parametric function. Okay, now what is the left hand side? Integration over c f bar dot d r bar. So in our case it is not f bar, it is a bar dot dr bar. So integration over c a bar dot dr bar. So a bar is given here, 1 minute. So it will be twice x minus y, twice x minus y dx plus then y z square j cap. Next term will be minus y z square dy, and then y square z what? Dz. Now there is a simple problem here. Since we are in the circle, no, there is no z, so we are in xy plane. Okay, xy plane. Since we are in xy plane, z equals to how much? 0. So if we put z equals to 0, you see this part will become 0, this part is also become 0. So we have only integration over c twice x minus y, how much? Dx, because these two part will vanish if we put z equals to 0. So we have only this part. Now we are doing the integration on the circle. See, here we get two variable x and y, but we have a single integration, so we cannot integrate it. So what to do? We have to convert it in single term. Single term means what? T. So when we write it in terms of t, so we have to take the limit of t only. So what is the limit of t? That I will explain. Now here what we can write? Twice x minus y, in place of dx we can write dx by dt into dt. You see dt cancel, again we will get what? Dx. But why we are converting like this? Because we have to transform this in terms of t. Okay. So let me write c here. We will write the limit in the next line. Now, since again x, y, t, now 3 variable comes, it should not be like that. It should be in terms of only t. So 2x, x is how much? Cos t. Y is what? Sin t. And what is dx by dt? This is our x, right? Dx, x is cos t. So if we differentiate it, you will get minus sin t dt. Now everything comes in terms of t. So since it is a circle, so on circle, the limit of t will be 0 to is 360 degree, no? Circle means 360 to twice pi. In place of t, you can write theta also. Now, since the integration is only in terms of t, so you can easily integrate it. So it will be t equals to 0 to twice pi. If you multiply, you will get 2 cos t sin t minus plus sin square t dt. So let us integrate it. Okay, first term you can write like this, no? T equals to 0 to 2 pi. This is nothing but sin twice t formula. And sin square t you can write half into 1 minus cos 2t. Okay? And dt. So integration sin t is how much? Minus will come. So cos twice t between the limit 0 to 2 pi. And for the next integration, half is constant. So take it outside. Integration 1 is t. And integration cos t is sin 2t by 2 between the limit 0 to twice pi. Now here, when you put 2 pi, it will become 4 pi. Cos 4 pi is 1. If you put 0, then also cos 0 is how much? 1. So it will vanish. And then here, when you put 2 pi here, it will be 2 pi. If you put 0, it will become 0. But see, in this part, if you put 2 pi, then sin any pi is how much? Sin any pi is 0. So finally, how much you will get? Only pi. Okay, only pi. So this is what? This is the left hand side. Now we have to go to the right hand side. So in right hand side, let me see what we have. Okay, now since right hand side is integration over s curl, curl. So let us find curl a bar. So it will be I cap, j cap, k cap, and a bar. What are the before that you have to write del x, del y, and then what? Del z. And then coefficient of a bar is twice x minus y. Then our minus yz square, and then minus y square z. So I think you all know how to expand this, right? So it will be how much? I cap into this row, this column vanish. So if you differentiate this, what you will get? Minus 2yz. Then this into this. Again it will be minus plus 2yz. So it will be cancel out. Minus j cap into this row, this column vanish. See, del x of this. So there is no x. So it will become 0. Del z of 2y minus 2x minus y, there is no z, so it will become 0. Finally, k cap into this row, this column vanish. So del x of this, there is no x, so again 0 minus. If we differentiate this, del y of twice x minus y, we will get minus 1. So minus plus 1. So you have simply k cap. Okay, only k cap we have. So with curl a bar, what we have? Curl a bar dot n cap. Okay, curl a bar dot n cap. So it's k cap dot n cap. Since a dot b is equal to b dot a, dot product is commutative, so this one you can write n cap dot k cap also. Now let us take the right hand side. Integration over s curl a bar dot n cap ds. So this is equals to integration over s. What we have? Curl a bar dot n cap. This is n cap dot k cap ds. So see ds. So you have to write two variables x and y. But before that, in surface integral, we have a relation. Now r, what is r? Inside the surface, whatever region you have, that I have written here r. So n cap dot k cap. In place of ds, there are some formulas I think you still remember. We can write dx dy divided by n cap dot k cap. So this particular relation you got in surface integral. So if you haven't watched it, then you can go and check it. Okay. So if you write dx dy, it will be k cap. If you write dx dz, then it will be n cap dot j cap. So now these two terms will be cancelled out. It's now very simple. You have double integration over r, simple dx and dy. So this one you have to integrate. But what is r? Where r is the, you can say projection also, projection of what? S on the xy plane. So projection means, so as I told, so if we take, suppose this portion, then its shadow will be in this part, no? So whatever shadow you get, it will be again some diagram. That region is how much? R. So if it is a three-dimensional figure, suppose hemisphere, half sphere, then its shadow will be a semicircle. So that is R. Okay. Now we have to integrate it. Since there is two variables, no, x and y, so we have to, so from where we will get the limit? So what is the circle here? X square plus y square equals to 1. So from here y square will be our 1 minus x square, and then y equals to what we can write? Root over 1 minus x square. Okay. So we cannot write plus minus because it's above xy plane. Oh, no, sorry, it will be not xy, plus minus. Okay. So integration, what we can write now? We'll write the limit of x later on. Let me write the limit of y first. Minus root over 1 minus x square to 1 minus x square. So suppose if it is given like that, bounded by x-axis, then we cannot take minus because here nothing is mentioned. So whole circle we have to take. So it is from minus to plus. Then inside what you have to write? Dx dy. Now what is the limit of x? So I already told you in the last video, if there are two variables, suppose x and y, so limit of x, y we find here directly, and when we find the limit of x, so in this particular circle, x square plus y square equals to 1. On x-axis there is no y, so we have to write like this: x square equals to 1 after putting y equal to 0. So x equal to how much? Plus minus 1. So it is from minus 1 to 1. So you can write this limit. You can write this limit from x equal to 0 to 1 also. Then what to do? You have to give 1, 2. Similarly, this integration also you can write 0 to root over 1 minus x square, and then 1 more 2 will come, so it will become 4. Like this also you can do dy and then dx. So let us integrate it. 4 into. So separately also you can integrate because, oh no, x will come. So x equals to 0 to 1. So what is the integration? Y between the limit 0 to 1 minus x square. Dx will be left out. So x equals to 0 to 1. If you put the limit, you will get 1 minus x square dx. So it's a direct formula of root over a square minus x square. So what is the formula? X into root over 1 minus x square by 2 plus a square. Our a is 1. Then sine inverse x by a between the limit 0 to 1. So here when you put 1, upper limit 1, it will become 1 minus 1, 0. If you put lower limit 0, then outside we have 1x. So in place of x, when you put 0, this part will become 0. So if we put upper limit, then also this is 0. If you put lower limit, then this part is 0. So first part is gone. Now half into, now here, if you put 1, upper limit 1, then 1 by 1 is 1. Sine inverse 1 is how much? pi by 2, and if you put 0 it will become 0. So what we have now? Pi into pi by 4. So how much we have? Pi. So you see what is our left hand side? Pi. And the right hand side is also what? Pi. So that means what? Stokes theorem is verified. Okay. Hence Stokes theorem is what? Verified. So it's very simple, right? So see, Green's theorem, Stokes theorem, and then Gauss divergence theorem. Everywhere you have to be a little bit master of integration. All are your undergraduate level integration. So if you know the integration very well, so it's very easy. So what is the new part here? Putting the limit. So, okay, and in almost all the problem in Green's theorem, Gauss divergence theorem, and Stokes theorem, the putting of limit is almost of similar kind, right? So if you understand how to put the limit of x, y, z, then it is very easy. Okay, so I hope Stokes theorem is clear to all of you. So in my next lecture, I'll do some more problems on Stokes theorem. So for that, kindly subscribe and hit the notification bell so that whenever I upload the video, you'll get the notification instantly. And thank you for watching.